Welcome to this Unreal Engine 4 beginner tutorial. This tutorial will be about creating our second beginner game. We will be taking what we have learned from the previous beginner tutorials and putting many of them together into one holistic view and making a game from it from start to end. We will make a game which has a couple of levels, or in my case exactly 3 levels, and we will have some elements of hierarchy, and we will have some elements of parenting, and will have some game instance and level transitions and some data tables, some enumerators. There will be a bunch of different elements all coming together into this series of episodes. So with that said, let's have a look at the game. So here we are inside of the engine with the game. So we have this very simple menu here where you get to choose a class, and depending on which class you pick here you get a different character in the game loaded in. So let's just pick warrior, we'll load in, and this is the character that we have. Now the warrior and the mage are obviously just placeholders for something else, it's just to distinguish them, but yeah, you would have different characters depending on what you choose. And in here we can see this sort of arena down here, or area. We're walking around on this glass surface, we're separated from the character down below, and all of these levels are just different shapes of and forms of puzzles. So for example, we have these buttons over here, we walk on them and when something happens we see that a gold ball spawns over there if we walk over it, for example. Then we have another button over here and we can press that and we see that the cover banister over there will start moving if we do that. So what you're supposed to do in this particular level is move the banister and then put the ball spawner in there, and it'll move down and hit the other character, and then the ball will take possession, so we now control this character instead. And the point of that being is that this character is actually able to go through the teleporter over here and get to a new level. Now on this level we have a little bit of a shooting puzzle. You have these bullets, different types of bullets that you can pick up in the level that have different properties. The point is to shoot this little trigger over there, and by doing that you open up the door to the left, so you can pass through and get to a different area. And in here you have a different type of projectile, a projectile that actually bounces, and this projectile is meant to shoot a different trigger over here, and that is opening up the door for the third area. And in here we get another projectile. This projectile is meant to be able to possess other characters, so we have a character over here, and if I shoot I can hit him and then I take possession over him, and then he has access to another teleporter over here, and then you end up on the final level, which is a platform puzzle where platforms disappear. And once you make it all the way through the very simple platforming part, you get to that little sparkly thing, which is the end of the level, and your game is over and you get a time for your total completion, which will be carried over between the different levels. So that's in basic words what we're going to be creating. So here we are inside of Unreal Engine version 4.26 if you want to follow along. So let's talk a little bit about the actual idea that we will be building around, and let me re-emphasize that this idea that if you want to follow along and do it exactly like I do, that might be beneficial, so that you name everything the same thing and you won't have any issues up until the end of the product or the solution. Then if you want to change things along, maybe in the end it's better to change along it, because if you change things during and you change things to have different naming conventions or different items or things like that, the consequence might be that you're unable to follow along the whole way with how you have made the project compared to how I've made the project, which might lead to difficulties. So I would suggest that you follow along and do it the whole way through, and then in the end, when you feel like okay, everything is done, everything is working like it should be, Then you can go in and do the changes that you want to have to make the game your own twist and your own product, and like have it your own feeling to it, and make all creative ideas that you want to have come alive. The general core idea though is gonna be we're gonna be collecting a lot of information from previous tutorials, and we're gonna be gathering them, making sure that they all come together in this one small game. So this game will be a simple puzzle game. We will have some different levels. I was thinking we will do 3 levels and a start menu that will just have some communication between them and some different aspects to them of tutorials that we've covered before. So for example, we will have a start menu where you will be able to choose a class. So depending on which choice you make at the start menu, you will have a different player character in the first level when you start playing. There won't be any difference between the two characters other than like something visual, so that we see that we have picked a different character, but that just shows you how you can have that data communicate for another project you want to do in the future, to have things transmitted in a similar way, but have that change be something else than visual. So maybe a character class like a warrior and a wizard, or something like that. Other than that, we will have 3 levels, and we will have small different puzzles in each of these levels, and they will all be centered around some concept of possession, meaning taking control of a pawn character. These puzzles will be different for each level, and we will have some variations to what you will achieve, but the general concept will be that whichever character that you are in the beginning is not the character that is able to complete the level, and you have to take possession of a different pawn to be able to get to a portal which allows you to bring yourself to the next level. And once you have completed all 3 levels, we can have something like time displaying how quickly you completed the whole level, basically, so you have something to work towards as a goal for going through the game. So that's going to be the general concept about what we will be creating. So let's start off with what we have here today. So we have a third-person template, and like always, I will have nothing used that you can't also use. Everything that is being used in this project is something that you can get either via the marketplace for free, or mega scans or something of that nature. So everything will be available and nothing will be off limits to you. What we want to start with is by going in the third person blueprint folder over here, and there's a folder called maps. There's a third person example map here. So we'll just rename this one by pressing F2 and call this level 1. Then we'll make a duplicate of this and call that level 2. And we'll make a duplicate of that one and call it level 3. And then we'll make a duplicate of that one and we'll call it main menu level. So these are going to be all the levels that we're going to be doing. They're going to be fine for now. We will be getting back to them and altering what they look like, but for now they all look like this level that we have open here. Next, we want to go to our content folder and we want to create a new folder, and we'll call it blueprints. This is where we will be maintaining our blueprints for the different objects. To begin with, what we're gonna be creating is something, a blueprint interface, because since we're gonna be making a puzzle, I was thinking we will be having a lot of simple pressure plates to begin with on level 1, where the pressure plates will be interacting with different other objects and somehow making them react. So this interface will be the way that we communicate with them and allow them to do something. So we'll go to blueprints and blueprint interface. We'll call this BPI underscore interact. And we'll open that one up. And we will rename the function that it auto-creates for us here to be interact with. And we'll save it. And should be that. Now we will be having first some pressure plates, and we'll be having some other objects that will react in some way. So let's start off with making the objects that will react. So we'll create a blueprint class, make it of an actor, call it BP underscore, and let's call it activatable objects. So this will represent our parent class, and everything that's derived from this will be the different types of interactable objects that we will have. So we'll go into this class and we will click on class settings and we'll add the interface we just created, BPI interact. Like so. And then we will implement the event and we'll leave it like so. I think we'll compile it. For the parent class we don't really need to do a whole lot. We'll get back to this with our objects in the future. So other than the activatable objects, we also want to have our pressure plates. So let's create those. So let's create a new blueprint of type actor and call it BP trigger. And then we'll open that up. Now we're gonna need a visual representation, like always. So we'll just take any and static mesh, we'll call it the trigger mesh. And we'll take the cube because the cubes are awesome. We'll scale it down a little bit so it's more like a platform you can actually stand on or trigger by standing on. Compile, save. And now we also need a volume for this, so that when someone is entering the volume, so we'll go for a box collision. And we'll make sure to scale that one so it covers the area of the mesh that we currently have. Something like that should be fine. We'll rename this to proximity volume. And then we'll go down on the right hand side for the volume and make sure that we click on component begin overlap. Now what we want to do is when we step on this platform, or actually we move in the volume but we act like it's stepping on the platform that's activating it, we want to make sure that something gets activated. And that is where we're gonna need a variable to this other object that we're gonna be activating with this trigger. So we'll call this connected object. And we'll make it of the type BP activatable object that we did before and make it an object reference. So we're gonna say if the other actor over here is a character, so any class derived from character steps into this volume or on this platform, then we want to get our connected object, and if it is valid, we want to send an interact message to it. So we'll do a valid. Actually, we'll take the other valid. Like so. So the cast has succeeded. It is a character stepping up. We have an object here that is valid, and we say we want to call the function interact with. Like so. So, no, that's the wrong one. Interact with. We want the interface call, the one that says in parentheses interface call. No, that's not the right one either. Interact with message is the one we want. My bad. Like so. You want to have the one that has a letter next to it, showing that it's sending something out into the void. So regardless if this object actually has this blueprint or this interface implemented doesn't really matter. If it doesn't, it's fine, it's just gonna not do anything. But if it does have this interface interacted, we're gonna do something now. So let's go back and create some interactable objects that we can use in conjunction with this trigger. So the way that I imagine that we are going to be changing which character that we're controlling is by possession of a ball. So we're going to be creating a ball by standing on one of these triggers, and if this ball hits a different character that we're interested in, then it's going to take possession over that character. So to start off with, we want to make another blueprint class that is a spawner, and we don't do it this way. We want to have it from the activatable object, so we want to right click on this and say create child blueprint class. We call this BP spawner. Now we can make a bunch of different sub-objects from this activatable object that does a whole bunch of different things. It doesn't really matter to the trigger. All it says that it has a reference to one of these objects. Doesn't matter what that object is, basically. As long as it has the interface implemented, it will send the ping to it as long when you stand on the trigger. So let's go into the spawner. Now our spawner is gonna do a very simple thing. It's just gonna have an implementation of the interact with event, and from that we're just gonna be spawning an object. So we're gonna be making a variable. We can call this a spawned object, and we can make it of a type, let's make it of an actor. Let's see, we have actor over there, and let's call it a class reference. So we will have a class reference over here, and we'll say is valid class, and we'll make a branch to make sure that it is a valid class. So this is just a validation to make sure that we have something that's spawnable, right? And then we'll just separate the functionality by making a custom event and say spawn object, and then we'll call the spawn object if this is a valid class. The reason why we do it this way is because if we were to make a child of this spawner, then all of this functionality is something that we want, and we just override this functionality and change that. So in here we could, for example, have this reference to this object and say spawn actor from class, like so. And we can say that this blueprint itself, the spawner, we can get its transform, and we just send it in there. So this is the base functionality. So let's make a little bit more advanced version of this one. So we'll make a child of this one, and we'll say that this is gonna be a class called BP Doomball spawner, like so. Then we go to the event graph. So now we have all of the functionality from the parent and everything like that. So the only thing we want to do is we want to override the function that we made, or the event that we made called spawn object over here. You find it under functions, under the overrides. Click spawn object. And now what we want to do is we want to spawn an actor from class, like so. And then we will spawn a new object here that we haven't actually created yet. So let's start with creating that before we continue. We'll just compile and save so we have it and don't lose anything later on. We'll make a blueprint class of actor, call it BP ball of doom, like so. And we'll go in here and we'll add a component. We'll make it a static mesh, like so. We'll call this is the Doom mesh. That didn't work at all. Let's try that again. So the placeholder mesh we will be using for this is a sphere. We'll take the one called shape sphere, like so. And in addition to that, we also want to add a collision component. Let's make this a sphere collision. And we'll call this one proximity volume. Now we need to, first of all, we need to move it up. So it's in the center of the ball. Then we need to uniformly scale it up so that it's covering the whole ball. Because the intention of this sphere is that this is the one that should be checking for collisions with other objects. And in this case, it's going to be a pawn. So we're gonna go down to the volume, and we're gonna overlap. Begin overlap component is what we're gonna be overriding or creating an event for. And we're just gonna check if the other actor is a character. Doesn't matter what kind of character it is. We're happy with anything. And we're gonna get player controller, and then we're gonna say possess. Then it's gonna want a pawn to possess, and we're just gonna send in whatever character. So whenever this ball hits another character class instance, it's gonna take possession over that, like so. So now we have our actual ball of doom. So let's go back to our doom ball spawner, and we'll change this to be our ball of doom, like so. And we want to get our transform again from this particular spawner, like so. So let's see what this looks like then. So if we try this out, we have a Doom Ball spawner. We'll put it in the world. We'll put it over here. And we want to have a trigger. So we put that over there. Now what we want to have is these to communicate. That's why we made a reference for the trigger over here. But we can't see the reference on the trigger here despite having it activated or selected. And the reason for that is because we haven't exposed it. Because to be able to see it here, it needs to be exposed like so. We go to our, where is it, the BP trigger, our connected object. You can either click the little square here. It doesn't necessarily, it isn't that obvious, but this is supposed to be a closed eye, like not seeing it. And if you click on it, it opens up and it becomes an open eye. This is directly connected to the interface, the instance editable checkbox over here. You can see that it changes when I click on the eye. So you can either click it over here or over here, depending on where you want to. So now we go back to our level and we see that connected object is now available. Now, if we were to click here, we will get a list of objects that we can choose. The list of objects that we will get will all be a BP spawner or some kind of child class from that, because that's what we made the object to be. Now in this particular case we only have one object available in our level, the BP Doom Ball spawner here, so we'll just click that one. And now these two are connected, so let's press play and see what happens. So we walk over the instance trigger and nothing seems to happen. Okay, let's troubleshoot this. So we'll go to our spawner and actually our Doom Ball spawner, and we will do a print and we'll check if this is spawn objects, like so. We'll play again. We don't get the message, so it doesn't get that far. Okay. So this means we don't get to this point, and we know that this point is dictated by the BP spawner checking the validation for the spawned objects over here.
So this means that our spawned object is not a valid object, and this seems reasonable because we haven't actually set it to anything, because our BP spawner has as default none, which means that our BP Doomball spawner, although we can't see it here, but if we click over here and show inherit values, is going to be none as well. Now what we want to do is we want to expose the eye. That way we can have a dynamically changed object if we wanted to. So if we go and do this, we drag the spawned object to the class over here, just like the parent. You see they're the same, and we can remove this print string. The reason we have they are identical right now, which means that they don't actually need to be, because we could have just had this empty, and then the parent would have called it spawn object, and if this one was set properly it would just work. But we will want some other logic after this later on, so that's why we are overriding this event for now. Let's go back into our level and we'll find our BP spawner. There's our Doom spawner, and we want to tell it that it's supposed to spawn a BP ball of Doom, like so. And we'll play again, and we see now that it spawns a ball. And that's good. But we want this ball to also be able to roll around in the level, so we need to activate its physics. So let's find the BP ball of Doom, the Doom mesh, and type simulate physics, like so. Compile and save, and check it out again. So now we have these balls that spawn from this spawner over there, which we can make use of. Excellent. Let's move on. So let's proceed with trying to see if our balls are actually going to possess a character like we're expecting. So let's find our blueprint for our third-person character and drag it out into the world. Let's try and align it so it's going to be under the spawner, so it actually hits it when it spawns. So something like that. So now the intention is we walk over the platform, we spawn an object over there, and we're supposed to be able to change over to this character. And now we're this character. So the basic concept is in place now. So now let's build upon this further. Now the way I imagine this is we want to have a puzzle where if we take this floor and we hold down Alt to copy it upwards, place it something like, I don't know, like that. And then we click on content folder, and since this has the starter pack and stuff like that, we have a bunch of things available to us. If we just type in glass, we'll find some materials for glass. So we'll just take this glass and drop it on this square that we copied. That means it's gonna be transparent. So what I'm imagining is something along the lines of this. We have our character. Okay, I copied it, that's not what I intended to do. I wanted to hold down shift. By holding down shift and translating a character, your screen actually follows along with the translation that you're performing, which might make it easier to move stuff around in some cases. Now this plane being transparent makes it a little bit difficult, but let's press end key and it should be putting itself snugly on top of it. So by putting a platform like this in between us that still allows us to see through, we will be able to interact and see what happens beneath it without actually being able to reach this space down here, which means that we can place our teleporter to the next level somewhere down here, meaning that we need to take control of this character that can actually reach the teleporter, right? So that's going to be the general concept. Now we just need to make it a little bit of a puzzle, like some simple puzzle. We will make a simple puzzle, and then once everything is done, you can feel free to expand upon that and make that puzzle how advanced or complicated as you want to. But we're just going to have something fairly simple to make sure that it's not super easy, but still not difficult, just so we can like get the concept down, right? So we proceed in this manner. Let's create another object of activatable object. So we'll create a child blueprint class and we'll call this BP Movable Platform. So this will be another object that we can interact with a trigger plate because it's inheriting from activatable object just like the spawner is. And we'll just put in some logic for this to behave in some way when it gets interacted with. So we need some visual representation again. So we'll use a static mesh to begin with. We'll call this the platform mesh. We will use the cube. We will scale it down so it becomes more of a platform, like so. And then we go to the event graph and we go to our interfaces here and we right click and say implement event. First thing we want to do is click over here and remove show inherited values so we get a little bit less of a clutter here on the left hand side. And then we'll add a variable which we will call start location. We'll make this a vector. And this is supposed to represent the start location for our platform measure. And this is to be able to know where it started and to know in relation to where it has moved as well. So we do a set start location and we drag in a platform mesh like so, and we say get world location. Then we plug these in like so. So that's the first thing we do. After that we want to start moving our platform, so let's create a timeline for that. Call it move platform like so, and tell it to play when it gets called upon. Now we enter the platform or the timeline for this and we add a float, and let's say we want to have this platform move in the span of 2 seconds. So that means we make the length of the timeline 2 seconds. We add 2 keys. The first key we have at time 0, value 0. The second we have at time 2, time 2, value 1. Yes, and then we can view both of them. We can also mark both of them and right click and click auto if we want to have a more smooth transition, like so. And that should be all that we need for now. Now we need to move this platform in relation to its size. Before we do that, let's go back in here and actually name this track, because I forgot to do that. Come on, there we go. Right click, rename, and let's call this platform move percentage. That's a very long name, but it is descriptive. So this is the amount of percentage that our platform has moved. Okay, so how much does it need to move? Well, it depends on our platform, right? So we need to get our platform, and we're going to use something called get local bounds. Now the reason we use this is because this should give us our information about how much space our platform takes up. So it allows us to be dynamic about how much it's supposed to move, because we're expecting to move the complete object out of its position to begin with, and if we go and change the size of the platform later on, we need to know we want to have it function regardless of the size of the platform. So what we can do is we can go out and drag a pin from min and break vector and do the same for max. So these will be 2 different points in our mesh here. So it would be something like this point over here and the point on the complete opposite, meaning that if you were to subtract one from the other, you would get the difference in height, in width, and in length, and you can use these individually to make some math. So what we want to do is we want to subtract the x from the min and the max. And that means we will get the difference between these two. The problem is we don't know which one of these is furthest to, which one of these has the lowest x value, right? Because it could be that this point has position 0 in x, and this has position 200, which means that we would get 0 minus 200, which gives us a value of minus 200. Equally, it could be that this has the position 200 and this has the position 0, which means that we'd get 200 minus 0, which is 200. So to make sure that we actually have a positive value here, we will drag out a node or a connector, and we'll type ABS, which stands for absolute, which will convert a negative value to a positive value, meaning that we're after this point we're sure that we have a positive value, and we're interested in a positive value because we want to have a dimension of the platform. Now that we have this, we want to multiply this with the percentage that the platform is supposed to be moving, like so. This should in theory allow us to move our complete length of our object when we have reached 100% over here. Now the last thing that we need to do is actually have this value drive where our platform actually is. So to do that we need to get our platform like so, and we need to set world location like so. So this is the value that we need to set, but we have only gotten one dimension here. We're only interested in moving, like for example left to right, or not any dimension upwards or anything like that. So we want to break this value, split the struct pin, so we get 3 separate values. But this leaves us with the problem that we can actually only put this value into one of these, which is a problem because what about the other values, right? Well, that's why we made the start location in the beginning. So if we get the start location and we break this vector as well, now we have our x, y, and z that we started with. So our new x should be whatever we started with, added with the value that we have said that we're going to be moving it with. We put that as our new x, and we make sure to plug in our y and z so they remain the same. And we send in an update for this. So let's see if this works. We put in a movable platform in here, and we'll put it over this character over here, and we'll put in another trigger in here. We can put it, let's put it to the left over here, and we want this trigger to be connected to that platform. So we need to again find connected objects, and we have only one movable platform in this case. And let's test it out. Okay, we also need to make sure that we actually have our platforms where we can reach them. Since we're now up here, we need to move the platforms to the height where our character is. So something like that, press end, they go down to the ground. So the left platform should be spawning the balls, the right platform should be moving the platform. Let's see how that works. So we spawn a ball. Okay, we have another problem, that we have our obstructing glass getting in the way of our spawner right here. So let's move this one a little bit. The reason for it is it seems like it's below it. The problem is that the ball that we have, if we go back to our ball of doom, you can see that it is actually the bottom of the ball is where this square grid goes, which means that this will be positioned above that position, meaning This ball here will be the bottom point of where the ball spawns, and the ball will spawn like so. So we'll put it down a little bit just to make sure it doesn't get in the way. Let's try this again. We spawn the ball, it ends up on the platform. We press this button and the platform moves away and our ball falls down. That's super advanced, but now we have control over this character. So that's all good and fine. Let's make some minor adjustments now. So like our ball, for example, our ball of doom. We don't want it to hang around forever. So when it begins, when it's created, we make sure that we timer by event. And then we'll make an event from that. Call it destroy ball. And we'll have that ball lasting for 5 seconds, let's say. And then when it has reached that point, we will destroy actor. So it will destroy itself. That means the ball will only hang around for 5 seconds. So if we were to step on the first platform to trigger the ball and then trigger the second one too late, then it wouldn't reach the player, for example. In addition to that, we also see that the platform doesn't actually go back over there. We want to have some kind of resetting mechanism for that as well. So let's go to our movable platform, and then when we have reached the point where we're finished, we want to play this in reverse, and yes, let's do that. So we'll make an event. I'm thinking about the best way to do this because we also want to have, let's make it like this. No, we'll have it play. So we'll make a custom event. We'll call this retract platform, and we'll just say reverse. That means it will reverse from whatever position it is at. Then we'll call it from here, retract platform, like so. Which also means that if it is on its way to be, if it currently is retracting and we step on the platform again, it's gonna open up again from wherever it currently is. So like we see, it goes back and forth now, but we can at any point go in and say go back. Actually, that isn't top notch. You see that it's teleporting the platform a little bit. That has to do with our setting of start location here. So we want to make sure that it doesn't reset the start location every time. Let us make use of some of the flow logic that we learned earlier. We'll do a branch over here. So we'll say once it's finished, it's going to go through a branch. And we're going to say we're going to make use of its direction here. So we're going to type 2 equal signs and check the equal enum here, which means that we can make a comparison of the direction here. So we can say if the direction is forward, then it should be retracting the platform. But if it has finished and it was backwards, then we want to instead reset the platform. I'll show you what we mean by that. So we'll make another custom event. Reset platform. And we will make it so that we right click here and do a do once. We'll say that we're allowed to do this once to activate this platform. Like so. Now we want to move it a little bit so. So we're allowed to go in here and interact with it whenever this gate is open. However, this gate will be closed immediately after having done this once and started this platform until it gets reset again, and it will be reset by this event over here. So it will only be reset once it has gone backwards and done finished. So reset platform. So that's how that logic will work. Let's see if it actually works in practice as well. So we'll step over it. Nothing should happen. It should be retracting until we get to the point where it has come back, and then you can see that we're allowed to make the platform move again. So that fulfills our needs for now. Let us create our way of teleporting between different maps. So we have done this a few times before, and in those times, if you remember, we had something called an enum. So we'll create an enum, and this enum is under blueprints and the enumeration. So we'll name it as e_levels, and we'll open it up. So we want to be able to transport to 3 different levels. It will be like we named our levels, our maps before, so it will be level 1, level 2, and finally level 3. So this is to make sure that we don't make typographical errors when it comes to teleporting, because when you say you open a level in Unreal Engine, you have a free text field which allows you to type in manually where you want to go, but by having it in an enum we can't actually make mistakes as long as we have actually named these correctly according to the maps that we made here earlier. After we've done that, let's make our actual teleporter. So we'll make it a blueprint class, and we'll make it of actor, and we'll call it BP teleporter. We open it up and we put something here as visual representation as always, just so we know where it is in the level. And we'll call this teleporter mesh. And in addition to that, we want to have a box collision because we want to make sure when someone enters it, so we call it proximity volume, like so. And make sure that the mesh is a cube because otherwise things will go awry. Make sure to scale it down, like so. And also we want to make sure that our proximity volume isn't hierarchical under the teleport mesh like I just did now, because when I scale down the mesh here, it will also scale everything that's beneath it, which means this proximity volume. So we'll start by moving it up to the default scene root and clicking attach, so it gets on the same level as the teleport mesh. Then when we have the proximity volume selected, we will make sure to scale it back up again. And then we scale it along the axis so it covers the platform. We scale it down a little bit, maybe move it up a bit, something like that. Then we create an own component begin overlap again, and we'll make a cast to character because we're only interested in characters entering this. And if it is a character, then we're going to open level by name, like so. And as it comes to levels, we want to have this as a variable on the teleporter, so each teleport can move to a different level. So we'll call this level to teleport to, this variable that we created. And we'll make the type of the e_levels enum type. And as a default, it's going to get level 1 because that's the first element in the list. So we're going to put that here. We're going to say toString. We're going to make sure to get the one that says user-friendly name of enumerator, and then we're going to hook it up to our open level, like so. Now that should allow us to technically teleport somewhere. So let's try that out. We'll put our teleporter down here. We will make sure to go back to the teleporter and make the teleporter level exposed, so we can set it in our level. So we'll make sure that it's teleporting to level 2, and then let's play. So what we need to do is we need to spawn the ball, we need to open the little platform, it should fall down, we get possessed over here, everything is good and awesome, and we run over to our teleporter over here and it should teleport us to the next level. And we know that this is the next level because there's no glass ceiling above us or platforms to move on, so this is the next level. So now we have all of that actually working. So that's good. By pressing escape now we get brought back to the level that we started from, so we're back at level 1 now. So now we have the very basic concept of the first level done.
This is the end of part 1. I hope to see you around for part 2. Keep on learning. Take care.